of lesson 1.2, the final few properties of functions that we're going to talk about, okay? And then keep in mind, you know, all of this 1.2 stuff goes together. There's a lot of different properties here, so that we've worked at. We're going to start today with talking about even and odd functions and how that relates to symmetry. So, did we talk about even and odd in Algebra 2? I feel like we did, but maybe we didn't. Okay, let me give you. Huh?
We did.
Okay. See, and I was kind of thinking maybe we did, but I don't know. So, here's what I'll tell you. Even and odd has nothing to do with whether the numbers are even or odd in the problem. Okay, not that type of definition. Okay. If a function is considered even, there's two different ways you can tell. Okay. Easiest option is to look at a graph. If you can look at a graph and you see that a graph is symmetric across the y-axis, then it is what we consider an even graph. Now, we don't always have access to a graph, and so algebraically, if a function is even, f of x is equal to f of negative x. So the function is equal to itself when you put negative x in place of x, and I'll demonstrate that, okay, and make that make sense. The other option, if a function is considered odd, okay, notice it has what we call origin symmetry. So that is symmetric about the origin. It's kind of, and again, I'll show you an example of that, what that origin symmetry looks like. But if you're trying to visualize it, it's kind of a diagonal symmetry. Okay, like what's in quadrant 1, you'll see down in quadrant 3 or 2 and 4 type thing. I also relate origin symmetry to its reflecting across both axes. So taking like what's in one quadrant and reflecting across the x and then also across the y. So you end up in that opposite quadrant. Okay? Algebraically, if a function is odd, f of negative x is equal to negative f of x. Now, kind of like I said with things like domain and range. There's algebra ways. There's graphing ways. My suggestion is you use them together hand in hand. Okay, there's some that'll be easier to tell with a graph. Sometimes they'll be easier to tell than algebraically. What's nice is when they agree, your answers agree with each other. So that's going to be my suggestion. So a few examples. Tell whether the functions are even, odd, or neither. Also determine their symmetry, which once you know if it's even, odd, or neither, we'll know what the symmetry is. Now, because the graph is the easy go-to option, I'm going to start with the algebra. Okay? So, we want to check things like is f of x equal to f of negative x, or is f of negative x equal to negative f of x? You know, that probably sounds like gibberish right now. Here's my suggestion, okay? We're going to start here. We know f of x, right? F of x in example A is given as x squared minus 3. So first thing I'm going to find is f of negative x. So in order to find f of negative x, every place I see an x, I'm going to replace it with negative x. So this is supposed to be x to the second. So I'm going to make this negative x to the second minus 3. Now we do cleanup. What is negative x raised to the second simplify out to be? X to the second, right? Because a negative times a negative is a positive. And so this is equivalent to x squared minus 3, yes? What do you notice here? They equal each other, yes? Right here, I just got x squared minus 3. What was my original graph? X squared minus 3. These graphs equal each other. If f of x equals f of negative x, what do my rules tell me? This graph is even. I don't have to go any farther. Okay? Once I find that f of x equals f of negative x, I stop there and I know that my graph is even. Your graph cannot be even and odd at the same time. So I'm done right there and I know that my graph is even. Now, the directions also said to determine symmetry. Well, based on the definition of even, what would you expect of your graph? Symmetric across the y-axis. Now, have you graphed it? Does your graph agree with this answer?
Yes.
I would argue that you would have to graph this if you think smartly here. Not all of you will agree with me. What do you guys know about x squared minus 3? Parabola moved down 3. So if this is a parabola moved down 3, it'd be different if it moved left or right, wouldn't it? But it's a parabola moved down 3. Does that make sense if we say that it's symmetric across the y-axis? Yeah, it's centered on the y-axis. So we can also say symmetric across y-axis. Okay. So that's an example of, first thing I'm going to check is, I'm going to check and see if it's even. Just because that's, the, you have to find that first one to get us started. Okay, ready for the next one? G of x equals x squared minus 2x minus 2. I'm going to start off the same way. I'm going to start off by finding g of negative x. Every place I see an x, I'm replacing it with negative x. So x squared, I'm going to write negative x in a second. Minus 2x, I'm going to write minus 2 times minus x. Minus 2. Now clean that up. Negative x raised to the second becomes x squared. Minus 2 times minus x becomes plus 2x. And minus 2 stays minus 2. What do you know right now? I don't know neither yet.
It's not even.
Can we agree it's not even? X squared minus 2x minus 2 does not equal x squared plus 2x minus 2. So right now, those are not equal. So what I have decided is that this graph is not even. Okay, we haven't graphed it on the calculator yet. And I've done that with you on purpose, but that we know it's not symmetric across the y-axis. That should be what you should see when you graph it later. Okay, so if it's not even, now we're going to proceed to check for, is it odd? If it's odd, f of negative x equals negative f of x. Well, what did we just find? We just found g of negative x, so we're halfway there. We now also need to find negative g of x. Now, negative g of x says that we're going to take the entire function and multiply by a negative. So if I write it out, it's one way of writing it is it's the negative of, and I'm going to put parentheses, x squared minus 2x minus 2. Well, if it's the negative of that, I'm multiplying every term by a negative. So x squared becomes negative x squared, minus 2x becomes plus 2x, and minus 2 becomes plus 2. Well, what did we just find out now? Okay, yeah. Is g of negative x the same as negative g of x? No, those two are not equal, and so now I can say that it is not odd. Well, okay guys, if it's not even and it's not odd, now we can officially say neither. So that means when you check your graph out, it's not symmetric across the y, and it's not symmetric across the origin. Did you check your graph out? What is your graph?
Parabola.
It's a parabola, but first one was a parabola, it was even. What's different about this parabola?
It's not the same.
Okay. Yeah, it's not centered on the y-axis, is it? It got shifted left or right. It's not centered, and so because of that, it's not symmetric across the y, and it's not symmetric across the origin. Okay. What was this one? X squared. Helps if you're typing. Squared minus 2x minus 2. So it's a parabola. A parabola itself is symmetric, but where this is located, it's not symmetric across the y. To kind of introduce you to the idea of symmetric across the origin, are my diagonal quadrants having similar pictures in them? No. Okay, and that comment will make more sense when I show you one that is. Okay. Questions there? Okay, next example. H of x equals x cubed over 4 minus x squared. I'm going to follow my same process, okay? First of all, I want to know, does h of x equal h of negative x? Every place I see an x, I'm replacing it with negative x. So it's going to be negative x raised to the third over 4 minus negative x raised to the second. What is a negative x raised to the third going to be? Negative x to the third, right? The negative raised to an odd exponent is negative over 4 minus, what is negative x to the second? Positive x to the second, right? So now keep in mind, it was already 4 minus. That negative x to the second is just positive x to the second. So this is 4 minus x to the second. Okay, what thoughts do you have here?
Not you.
Okay. Right now, does this match my original? Nope, we're off by a sign. So right now, I know this is not even. Okay. Next, I want to find negative h of x. Now, negative h of x means we take the whole equation and multiply by a negative. This looks a little different with it being a fraction, but I'm going to put, so like I did previously, I'm going to put my negative out front, and I'm going to write the function in parentheses, so the negative of x cubed over 4 minus x squared. Now, to multiply a fraction by a negative, what does that mean? Are we multiplying top and bottom both by negative? Just, and here's what I'll say. Jaren says just top. I'm going to say just top or just bottom. If you multiply both by negative, a negative over a negative is a positive. So when you're multiplying a fraction by a negative number, some people will say you have to multiply the top by negative. I'm going to say you can choose. In this case, where does it make sense to multiply the negative to? I would say, based on what my h of negative x function is, I would say multiply it to the top. Because if I multiply it to the top, this becomes negative x cubed over 4 minus x squared. And what happens now? They equal, don't they? Right here, negative x cubed over 4 minus x squared. So h of negative x equals negative h of x. Maybe I should have done equals? I don't know. So, based on our definitions, what do we know here? This is odd. Now, we haven't even looked at the graph yet. I'm going to because I want you to see this graph. What's this mean about symmetry?
Symmetrical about the x-axis.
No. Look at your definition. Symmetric?
Origin.
Yep. Symmetric across the origin. And that is, we haven't looked at the graph yet, but that is solely based on our definition. If a function is odd, it is symmetric across the origin. Okay, this graph is an important one to look at in my brain. What do we have? X to the third over 4 minus x. Because I want you guys to have an idea of what something that is symmetric about the origin looks like. And it's hard for me to explain, to be honest. Okay, this graph is symmetric about the origin. Okay, I'm going to put a little sketch up here. Okay. If I take this graph and I reflect it twice, so reflect it across the x-axis, reflect it across the y-axis, it's going to land on itself. Visually, for me personally, the easiest way to do this is to think one quadrant at a time. So like if I take just first quadrant, okay, if I just visualize that first quadrant, and I flip it, doesn't matter which axis you go, so if I flip it across the x, now it's upside down. If I then flip it across the y, now it matches up with what's down here in quadrant 3. I can do the same thing with, like, say, quadrant 2 up here. Okay, if I think about that quadrant right there, flip it up and down, and flip it sideways. Okay, so if I want to flip it sideways first, okay, now it's over here, and then I flip it down, now it's over there. That's easiest, those are the ways I can explain it. Okay, but diagonal, does that kind of make sense? I don't know. Okay. Questions there? Okay, what's my next section? Asymptotes. Okay. Let's talk a little bit about asymptotes, and we'll have to pick up here tomorrow. Whether or not we talked about even and odd in Algebra 2, not 100%. You know, sure. I'll figure it out for sure.
We did.
I feel like we did a little
We
bit.
just didn't do any graphing.
Okay. Well, and you wouldn't have had access to graphing calculators, so.
But I don't know. It sounds. At least we did something like it where we had to plug in things and figure out which one it was.
For the thing that we just did, are we gonna have to show our work like on our test and stuff? Or can I just put her in the graph and get the answer?
Okay, so on this, I don't usually specify how to decide if it's even or odd.
Okay.
Okay, my suggestion is always to think about them both, just so the graph doesn't fail you or the algebra doesn't fail you.
Okay.
But yeah, technically you can plug it in the calculator, and if you're clear on what the graph looks like, that can work for you. Yep. Okay. Asymptotes. You did do asymptotes in Algebra 2. Okay, no doubt about it. So these rules should sound vaguely familiar. Okay, we're going to talk about vertical asymptotes and horizontal asymptotes. Vertical asymptotes are always of the form x equals a number. Okay, because that's what a vertical line is, right? It's x equals some number because it goes through the x-axis. Now, vertical asymptotes, we've been talking about this the last couple of days. These are places that make your denominator equal to 0. How do we find asymptotes, vertical asymptotes? We take the denominator and set it equal to 0. Okay? If the equation needs to factor, you're going to factor it to find those pieces. The other option, and this is one that takes a little bit more, horizontal asymptotes. Well, horizontal asymptotes, they are horizontal lines, so they're going to be expressed as y equals a number. They depend on powers. Where is your biggest power? So, if the biggest power is on top, then there are no horizontal asymptotes. Okay, so if you're looking and you've got something where you have the biggest power of x cubed on top, x squared on bottom, biggest power is on top, there's not going to be any horizontal asymptotes. We'll talk about slant asymptotes later that might exist, but there won't be horizontal asymptotes. If the biggest power is on bottom, then y equals 0 is always the horizontal asymptote. So that would be like if you had x squared on top as your biggest power and x cubed on bottom as your biggest power. Y equals 0. Or if it was x to the third over x to the seventh, biggest power still on bottom, you still have that y equals 0. And then lastly, if powers match on top and bottom, then you take the coefficients of the biggest power. You use that. So my example here, y equals 3x cubed over 4x cubed plus 1. Okay? What are my biggest powers? Well, they are both x cubed, yes? Since my biggest powers are both x cubed, what are the coefficients of those terms? 3 and 4. So what's my horizontal asymptote going to be? Y equals 3/4. Okay? So those are our different asymptote rules that you will need to be very familiar with. Okay? So tomorrow, we'll look at this example where it asks us to find any asymptotes, and we'll look at what makes the graph do. And then we'll talk about in behavior, which in behavior is basically horizontal asymptotes. And I would think with that, you would have some work time tomorrow.